Hello friends, I want to have a discussion about the plasma discharge-based circuit breakers. In fact, I want to talk about their types and their current status. Circuit breakers are designed to protect the electrical systems from dangerous fault currents, in fact high currents. When a fault occurs, they act by interrupting the flow of electricity. In discharge-based breakers, the interruption process involves the plasma physics. Then there are many discussions, many issues which are related to the plasma physics in the circuit breakers. As the contact, in fact metallic contacts, get separated, plasma arcs naturally form between them. These plasma arcs are controlled and extinguished to prevent the damage and ensure the safe system operation. But what makes them discharge based, or what makes them plasma discharge based? When breaker contacts open under the electrical load, the current does not stop immediately. Instead, it continues briefly in the form of a plasma arc. The arc must be controlled to avoid damage and hazards. Discharge-based breakers use different media such as oil, air, SF₆ gas, and vacuum. These media stretch, cool, extinguish the arc, ensuring safe interruption of very high voltage and currents. And this is very much important. This is this is the associate mechanism. This is some kind of associate mechanism among these different circuit breakers. I want to continue my discussion about these four different circuit breakers. I will start from OCB, or oil circuit breakers. Oil circuit breakers use insulating oil as the medium for arc extinction. During an arc, the oil vaporizes and produces the gas bubbles. These gas bubbles help cool and quench the plasma. Then we will have stopping the current safely. Historically, oil breakers were widely used and considered effective. However, they are bulky and they present fire risks and they require heavy maintenance, so they are now being replaced by safe modern technologies. The second category of circuit breakers, or gas discharge, plasma discharge circuit breakers, is related to air blast circuit breakers. Air blast circuit breakers use a strong jet of compressed air to extinguish the arc. The air blows through the arc channel and quickly forces it to collapse. This method made air blast breakers suitable for extra high voltage applications. However, they are very much noisy and mechanically complex because they require a constant compressor system, and they are now considered outdated, and they have mostly been replaced by the gas insulated breakers. The third category of gas discharge or plasma discharge circuit breakers is related to SF₆ gas circuit breakers. SF₆ gas circuit breakers use sulfur hexafluoride gas as the interrupting medium. This gas has a very high dielectric strength and excellent cooling properties. These features make the breakers compact, efficient, and highly reliable. They can operate safely even at a very high voltage. But however, SF₆ is known as a powerful greenhouse gas, and there are many R&D activities which are focused on finding eco-friendly alternatives. And finally, the fourth category of gas discharge or plasma discharge circuit breakers are vacuum circuit breakers. In the vacuum circuit breakers, the contacts open inside the seal channel. Then the pressure is very, very low, and in fact, we have a vacuum medium. In this vacuum environments, arcs cannot be sustained for such a long time. The brief arc that appears consists only of a vaporized metal from the contacts. In fact, contacts or electrodes are metallic, are made of metals. This vapor condenses quickly, which makes the design clean, durable, and low maintenance. Today, vacuum circuit breakers are widely used in medium voltage networks and are steadily replacing the older breaker technologies. About the technology evolution, circuit breakers technology has gone through the several major stages of development. The earliest designs were bulky oil breakers. These were followed by noisy and complex air blast breakers. Later on, the compact and efficient SF₆ gas breakers became dominant in high voltage systems. But today the shift is toward the vacuum breakers and eco-gas designs that are smaller, safer, and more environmentally responsible. In conclusion, I would like to tell you that gas discharge or plasma discharge circuit breakers are still vital in modern power networks. This is because of this fact that the high voltage switching always produces plasma arcs with high currents that must be extinguished safely. Oil circuit breakers and air blast circuit breakers are now considered obsolete. But SF₆ breakers remain widely used, but their environmental impact is a serious concern. But vacuum circuit breakers are the modern standard and eco-gas technologies that are expected to shape the future of circuit breaker designs. Thank you.